Section 5.2a is about direct variation. A direct variation is an equation of this form, y equals a number times x. Now, anytime you see an equation in that form, it's called a direct variation. The number in front of the x, we use the letter k to describe it, and it's called the constant of variation. Now, two important things to note about direct variation. They all pass through the origin, which means they all go through the point 0, 0 in a coordinate plane, and the direct variation, the k acts just like a slope. So anything that you know about slope also applies to the k in a direct variation. Here we're asked to find two things. We're asked to name the constant of variation, and then we're asked to find the slope. Hopefully you'll find this very easy, because remember that in a direct variation, which is what this is, y equals 3x, they all go through the origin, and the k, which is the number in front of the x, is right here. So we know that our k here is a 3, because it's right in front of the x term, and we learned that in the last slide. Now we have to find the slope. Well, we could do slope, we could do rise over run. We could start at this point and go up 3, so the rise would be a 3, and then the run would be to the right 1, 3 over 1. So we could find slope that way and get a 3. But there's an easier way to find slope, and that's because we said in the last slide that the slope and the k act just like each other. So if the slope is 3, or excuse me, if the k is 3, then we know the slope is 3. It's that simple. In this one, we have our direct variation, y equals kx. So we see that the k is right there, equals -2. And we could try to calculate using rise over run or the formula what the slope is, but we know that slope and k are the same thing, so my slope is -2. Here we have to graph this equation, y equals x. We know it's a direct variation because it's in the form y equals kx. In fact, if you wanted to rewrite it as 1x, you could, so you know the k is 1. Because it's a direct variation, we know the two facts that it goes through the origin and the k acts like the slope. So we can use that. Go over here to our graph. We know that we're going to start here at the origin. We know that there's a point there that this goes through because it's a direct variation, so we can just put a dot there. The other thing we can say is the slope is 1, or the m is 1. Actually, I don't know, you might want to say the k is 1, therefore the m is 1. And since it's 1, we can write it as 1 over 1, which means my rise is 1, and my run is 1. So rise means I'm going to go up 1 and to the right 1. So let me do that the same way I've been doing it before. Up 1 to the right 1. That's my slope. So I know that there's a point there. And I can actually keep repeating that. Up 1 to the right 1, up 1 to the right 1, and I can keep building dots here, and eventually I'd be able to see that this is my line. So there's the graph of y equals x. Here's another direct variation I have to graph. It's in the form y equals kx. I can see the k is -3/2, therefore I know my m, or my slope, is -3/2. So my rise is -3, and then I can say my run is +2. Now because it's a direct variation, we know that it goes through 0, 0, so we can always just start right there. Now I'll do a rise of -3, which means I'm going to go down 3, and to the right 2, doing my rise and run. So I know there's a dot there, and I can do that again, down 3 to the right 2. Put a couple points on there, and now I can graph my line. So there you go. That is the graph of the direct variation y equals -3/2 x. Here we have some definitions. A family of graph includes graphs and equations that have at least one characteristic in common. An example of a family of graphs would be something like this: y equals x, y equals 4x, y equals -2x. They're all direct variations, so they're a family of direct variations. They just have different k's. Now another definition, the parent graph is the simplest graph in that family. We would say it's this one, y equals x is probably the simplest graph. Moving down here, when you read a direct variation, or when you look at a direct variation that's in this form, you should think of the sentence, y varies directly as x. What does that mean? That means y changes. That's what varies mean. Y changes directly as the x changes. And the k is the number that decides how the y changes. If you go up here to this one, for example, If you put a 1 in for x, you get a 4 for y. If you put a 2 in for x, though, you get an 8 for y. So the y changes based on what number you plug in for x. The point is, whenever you see the phrase y varies directly as x, you need to think of this equation, y equals kx. So here's an example that says the phrase y varies directly as x. When you see that phrase, you need to start with y equals kx. That's just the way it is. Now, a couple things we have to do. We have to look at when y is 9, when x is -3. And then we have to write a direct variation. Well, writing a direct variation means finding the number for k. How do we do that? We plug in the 9 and the -3. So here we go. When y is 9, x is -3. Now I have to solve for k. Divide both sides by -3. 3 goes into -9 3 times, so k is -3. So I can now write my direct variation, y equals -3x. And that relates x and y.